everyone. Today we're going to go over arithmetic sequences. So today we're going to be able to write the terms of an arithmetic sequence and extend a given sequence. So a sequence is an ordered list of numbers, and each number in a sequence is called a term. So an arithmetic sequence is the difference between each pair of consecutive terms to see if it's the same. This difference is called the common difference, and each term is found by adding or subtracting the common difference to the previous term. And understand, an arithmetic sequence can never have multiplication or division. So one thing to note is that in a sequence, our very first position is actually our first term, and each position here is represented by n for the nth position for when we're looking for it. So in a moment, we're going to be able to write arithmetic sequences, but first, let's see if we can find the common difference. And I'm going to label common difference as CD. So we're going to take a look at our arithmetic sequence and see what the common difference is, and then be able to write the next three terms of this sequence. So from -2 to 6, we see it's going up by 8. And we want to double check to make sure they're all going up by the same amount, in which in this case, it is. And I put plus signs to represent going up and negative signs to represent going down. So in our case, our arithmetic sequence is going up by 8, which is our common difference. And all I need to do for our next three terms is to add 8 to the one prior. So 22 plus 8 is 30. 30 plus 8 is 38. And 38 plus 8 is 46. And those are our three terms. So now let's look at our next one. We have our next arithmetic sequence. 1.1, 1, 0.7, and 0.4. So let's first find our common difference. We can see that it's going down, so we'll have a negative common difference, and it's going down by 0.3. So that means we just need to subtract 0.3 from our prior terms. So we're going to be left with 0.4 minus 0.3 is 0.1. 0.1 minus 0.3 is negative 0.2. And our last one is negative 0.2 minus 0.3, which gives us negative 0.5. And those are our next three terms of our arithmetic sequence. This part isn't so bad. You're just finding your common difference and then applying it to your next terms. But we can also represent arithmetic sequences by graphing. So the unique thing is we're going to graph the arithmetic sequence 24, 18, 12, and 16. What it actually means is 24 is our first term. So it's going to be 1, 24. Our next one's going to be 18, so 2, 18. And so on and so forth. Because which position they are tells you which x value it is. And then we're going to label our graph. Our x-axis is counting by ones, since our x values are only going up by 1. And our y-axis, I'm going to go up by 6s, because I'm noticing a trend in this possible arithmetic sequence. So we just graph this. 1, 24, 2, 18, 3, 12, and 4, 6. We notice that it looks like it has a negative correlation. Because technically this is a scatter plot. But also, it is decreasing at a constant rate. If it is not increasing or decreasing at a constant rate, it cannot be an arithmetic sequence. So we're going to see if we can identify an arithmetic sequence from the graph. So we're going to look at our first one. We're going to see if it represents an arithmetic sequence. So we're going to first take a look at our x values. I can see that our x values are increasing by 1. And our y values, I can see going from 1.5 to 3 to 4.5 to 6. It is increasing by 1.5, which means we have a constant rate. So therefore, it is an arithmetic sequence. And in our second one, we're going to do the same process. We're going to look at our x values and our y values. Our x values show that we are increasing by 1, so good start. Let's take a look at our y values. We see that our y values are 2 to 4, which is increasing by 2. So if our common difference is 2, we should only be needing to go up by 2. However, we see that our next number is 7. So that automatically shows that we are not increasing at a constant rate. And the moment we find that one of our values is not increasing at a constant rate, meaning our common difference is not consistent, it is not going to be an arithmetic sequence. So we are able to extend an arithmetic sequence, we are able to graph an arithmetic sequence, and being able to identify it from a graph. But now let's talk about writing. So we can take a look here that the position represents which area it is on the terms. And we can see how as you move forward, as you go forward and see where we could get to the nth term. And I want you to understand that n in our equation over here represents the number of terms you are looking for, typically given in a subscript of a. So we're going to be able to write an equation for the nth term of this arithmetic sequence and then find the 30th term. So we're going to follow along. We're looking for our first equation. So a sub n equals our very first term. And our very first term in this sequence is 100 plus, we're going to do n minus 1. That stays consistent until you solve for with the number. And n is going to be 30 here in a minute because we're looking for the 30th term in the sequence. And our common difference we can find by seeing if it goes up or down by a certain amount. In this case, we can see that 100 goes to 110, 120 to 130. So it is increasing by 10. And now that we have the equation for this arithmetic sequence, we are able to find our 30th term. It's going to look exactly the same, but we just need to substitute in 30 for n and then solve. And again, I'm putting plus signs to denote that my common difference is positive. So off screen, I am going to do the calculations. 30 minus 1 is 29. 29 times 10 is 290 plus 100. So we get the 30th term for this arithmetic sequence to be 390. Not terrible. Now, let's do another arithmetic sequence and write another equation. So first we're going to set it up going a sub n equals our very first term. In this case is 7 plus parentheses n minus 1 in parentheses, and now we need the common difference. So we're going to take a look here. I see the numbers are going down, so our common difference is negative. And it's not just going down, it's going down by 4. So our common difference is -4, so going down by 4. From here, I can find a sub 30, or the 30th term in the sequence. You can actually use this arithmetic sequence equation, to be able to find any number of terms that you want. So refilling in this information, not in this time, I need to put 30. And some off-screen calculations will give us our 30th term, which I am doing currently. We shall get the 30th term of this arithmetic sequence to be -109. But let's use some real world stuff. We all have hopefully seen a movie before. So we're going to take a look here at this model and see that we can first check, because we're working on arithmetic sequences, it's going by a constant rate, which you see our x values are doing that, and so are our y. So first check, good. So the amount of money a movie earns each week after its release can be modeled by a sequence shown in the graph, which we just first checked. Our x-axis represents the number of weeks that the movie is taking place, and the y-axis is talking about the millions of dollars that movie has earned. So first we're going to write a function that represents the arithmetic sequence. So we're going to get a sub n equals our very first term, which is 56, plus n minus 1, and then our common difference, which is going down by 8. And that is our function. Now it's asking us, in what week does the movie earn 16 million? So since weeks is our x-axis, is also represented by n. So since we're looking for n, that means that we have earned 16 million, which is our a sub n. So that will be 16 equals 56 plus n minus 1, because we're solving for n, -8. To solve this, we just distribute -8 to n and -1 quickly. So I'll get -8n plus 8. I'm going to combine my like terms and get 16 equals 64 minus 8n. I'm going to subtract 64 on both sides. And I'm going to get -48 equals -8n. So dividing both sides by -8n, we find out that it is the 6th week that the movie will earn $16 million. Then we look at C. How much money does the movie earn overall? So that means our very first step is to figure out when the movie does not earn any money. So when our y value is 0, or a sub n. So let's first figure out, how long does it take for the movie to quit earning any money? Because it makes no sense to keep a movie in theaters when it's starting to lose money. No one likes losing money. So we're going to set our a sub n to be 0. And we're going to do the same process as before, but with a different number. But that doesn't mean we are done with this, because we just first have to figure out what we get ends, and then we got to find how much money it earns for every single week until it makes no money. So we're going to get, same process, go ahead and distribute. Combine like terms. Move 64 to the other side. And divide both sides by -8. And we can see that in the 8th week, the movie is going to earn $0. So that means we know we just got to figure out how much money this movie earns in 8 weeks. And luckily for us, there is a pattern and we have most of this information. So we know in the 8th week, it'll earn $0. In the first week, it earns 56. Our second week, it earns 48 million. Our third week, it earns 40. Our fourth week, it ends 32. And we've already calculated our 6th week in part B, which is 16. And from here, you are capable of using your arithmetic sequence function to find week 5 and week 7, or you can look at a pattern. Since arithmetic sequences go up and down by the same amount, we can see here that it is just decreasing by 8, which is stated by our common difference, and we can fill out the rest. Now that we know how much money the movie has earned for 8 weeks, we are going to add them all up. We're going to find the sum, which we can use this Greek symbol for sum. So we're going to have 56. So we're going to have the sum of 56 and 48 and 40, 32 and 24, 16, 8. And I'm just going to put 0 there because it makes sense. So we're going to do some off-screen calculations and add up all these numbers to find the sum. And again, that big E looking thing just means sum. You're going to get the sum of all those numbers. And we find that the movie earns $224 million in just 8 weeks. That's a lot of money. But that is where arithmetic sequences could be very important in real life, is to figure out how long does it take to earn no money and how much money can you earn overall. So businesses can look at a model to determine what is going to be the most useful for them to earn a profit. I appreciate you for being here today, and I hope to see you again some other time. Thank you.